Hello. The topic is two-dimensional collision. Okay. So in two-dimensional, we will be talking about the theory is exactly the same as in one-dimensional, right? So theory stay the same. It's just that now we have x and y, right? So this is just now we have x and we have y. And so we have to think about this as a vector a little more, right? All right. So then let's say if we have one ball and it's going this way, okay? And let's just say this is M1, it's equal to 1 kilogram. And you have another ball that's not really heads on, so it's a slightly off, say right there, okay? So when this comes over, after the collision, this M1 goes this way, for example. So this is V1 prime, okay? And this is V1, let's say equal to 1 meter per second. And V1 prime, let's just say that's equal to, say 1/2 meter per second, okay? And let's say this is, say 30 degrees, okay? Right, and then this is M2. M2, let's also assume is equal to 1 kilogram. And it was initially at rest, so V2 is equal to 0, right? So now what we want to find out is, we know that this ball also going this direction, and this angle here, it's also 30 degrees, okay? We know that. But now the question is, what is V2 prime equal to? Okay, can we do that? Okay, so let's look at this problem. So let's look at x direction. All right, so don't forget this, right? In order for what we are doing here, this 2D collision, to be okay, we need to have summation F, right, in net force in the x direction equal to 0, plus summation, right? So the net force, right? So all the forces, we don't need a net there, or we just say net force in the x direction, right? And net force in the y direction. So both of them has to be true. Then we can apply conservation of momentum. Conservation of momentum, all right? So x, let's look at x now. So x is this direction, and y is this direction, right? So we know m1 v1 x plus m2 v2 x is equal to m1 v1 x prime plus m2 v2 x prime. All right, so that's conservation in the x direction. So this is conservation in the x direction. Okay, so we have that, and then we have y also, but we're going to look at x first. So 1, right, times v1x. So this is v1x, right? So that's times 1 plus m2 was initially 0, right? So m2 is 1, and v2x initially, v2 is 0, so this must be 0. It's equal to m1 is 1 again, and v1x prime, okay? Let's look at this. So this x prime is going to be m1 times v1 prime, which is 1/2, and then this direction, so cosine 30 degrees, right? So cosine 30 degrees, that's 0.86, right? And then plus m2 is 1, and then you have the v2x prime, okay? So this is going to be v2x prime. right? So from here, you can find out what's V2x prime. So then you can solve for V2x prime. Okay? It's equal to how much? All right? So let's try to solve it here. So it's going to be 1, where's the V2? For one, V2x prime. V2x prime is equal to 1 minus, right? So plus this, right? So you move to the other side, minus 0.43, right? So that's going to be 0.57, okay? So V2x prime is going to be 0.57. So you can see that, right? So how about let's change color here. Let's change color to green. And now let's look at the y direction. So y direction, you have m2 v2, m1 v1y plus m2 v2y. It's equal to m1 v1y prime plus m2 v2y prime. Okay? So let's take a look and let's plug in the value. So m1 is 1 and v1y is 0, right? Because it's only in the x direction. m2 is 1 and v2y is also 0 because v2 is 0, which is equal to m1, 1 times v1y prime, right? So v1y prime is going to be 1/2, right? Times cosine sine 30, right? So that's sine 30 is 1/2. So times 1/2, and then plus m2. M2 is 1, right? 1, and then v2y prime, right? v2y prime. Okay? So that's what we got. We can now solve for the v2y prime now. So v2y prime, it's equal to 0, right? This is 0, equal to minus 1/4, right? Okay? So that's what we see. And so this one here is going to be this guy there, right? And v2x is going to be positive, all right? So we find this, right? So that's how you solve for a 2D collision problem, and you just divide it into x and y directions. So let's recap, right? So in this problem, right, you do a 2D collision problem, okay? So you just do x, and you find out that Fn in the x direction is 0, so you can apply your conservation of momentum, okay, in the x direction, right? So then you have P1x, so that's momentum, plus P2x is equal to P1x prime plus P2x prime. In the y direction, you do the similar things, right? Fn in the y direction, then your conservation in the y direction, conservation of momentum in the y direction. So now you have P1y plus P2y equal. Remember, you got to watch out for the sign, right? The velocity, you got to watch out for the sign. Be careful with that. And you have P1y prime plus P2y prime. All right, so that's all we have, and have a good one. Hopefully you get to